All right, taking a look. Got some more no calculator problems. The limit as x goes to 2, so the limit at a point. And if we can't just put in the 2, which would make this undefined, then we should try to factor. And the top factors into x plus 3, x minus 2, and our denominator factors into x plus 2, x minus 2. Those will simplify. Now I can put my 2 in, and I'll get 2 plus 3, 2 plus 2. Good there. And look in here. If this is our function, then our derivative at 2 is, so let's just find our derivative. Got our power rule. F prime of x is 3x squared minus 2x plus 1. And if we just put the 2 in, 3 times 4 minus 2 times 4 plus 1 should be 13 minus 8. I get 5. Oh, some nice ones right off the bat. Which of the following definite integrals has the same value as this one? So how would we integrate x times e to the x squared? I think we'd probably make a u substitution, and all the way inside is that x squared. So if u is x squared, then du is 2x, which will take care of that x. And now if we also change our limits, if x was 0, 0 squared is still 0. If x is 4, 4 squared is 16. So our new limits are 0 to 16. And because I've got a 2 here, I need a 1/2 to undo that 2 in front. So 1/2, 0 to 16, of e to the u du. There we go. Which one is that? Cool. Which of the following is an equation of the line tangent to the graph at the point? So we've got to write a tangent line, which means we've got to write a slope. To write a slope, we need a derivative. And I think we do have two options here. We could subtract, divide, and then find a quotient rule to find a derivative. Or I like the idea for a review of practicing our implicit differentiation. So we're going to do the product rule on this 3xy. Derivative of x is 1. The derivative of y is that dy dx. I think this is a good implicit review problem. So let's derive. Derivative of x squared is 2x minus 3x dy dx minus 3 times the 1 times the y equals, derivative of 10 is 0. Then I can get the dy dx by itself by adding the 3y over, subtracting the 2x, and dividing by the negative 3x. So I'm going to do that just in one step. Dy dx equals, add the 3y, subtract the 2x, divide by the negative 3x. And then I can put in the 1 and the negative 3. 3 times negative 3 minus 2 times 1 over negative 3 times 1. So 9 minus, negative 9 minus 2 is negative 11 over negative 3, which would be 11/3. And if I look, the only function with a slope of 11/3 is e. Good little implicit review. If g is the function given by this, on which of the following intervals is g decreasing? Well, g is decreasing when its derivative is negative. So if I find my derivative, let's do that. A nice little convenient derivative here. G prime of x is 3 times 1/3 x squared plus 3/2 times 2x minus 70. So if I find where my derivative is equal to 0, then I can find where it's decreasing. So if I factor x plus 10, x minus 7. So x equals -10 and 7. That's when the slope is 0. I want to know when the slope is negative, so I can do my first derivative test. -10 and 7 are going to be my zeros. If I put in a number less than -10, like -11, I'll get a negative times a negative, which is actually a positive. If I put in a number like 0, I'll get a positive times a negative. And if I put in a number higher than 7, like 10, I get a positive times a positive. So the only place it's decreasing is in there, from -10 to 7. Great. Keep it up.